This video will discuss chapter 10.8, trigonometric ratios. And so this is what a lot of people call trig for short. And many of you hopefully are excited to get into some of the trig, as it's often considered a very complex subject. I want to kind of break down a few of the major ratios that we're going to study. Sine, which is actually spelled S-I-N-E, but in the calculator and often in math you'll see it as S-I-N. Okay, but this is sine. Sine is the ratio of the opposite leg over the hypotenuse. Cosine, spelled like this, so you often see it as C-O-S, whether it's on a calculator or in a textbook, is the adjacent leg over the hypotenuse. And tangent, which is T-A-N, is the ratio of the opposite leg over the adjacent leg. You may want to pause the video at this time to write down these ratios. We're going to use these ratios a lot, so I'm actually going to place them back here. Hopefully they'll remain on camera for a while as we're working on some of these. And so if you want to take a look at what this might look like as a problem, if I'm looking at this triangle, remember that trig ratios only work on right triangles, like the Pythagorean theorem. It has to be a right triangle. If you call this a triangle ABC, C is my right angle. If I'm looking at angle A, the sine of angle A is the opposite over the hypotenuse. So it's the ratio of A to C. Okay? The cosine of A would be the adjacent over the hypotenuse. So keep in mind that when I'm looking at angle A, one leg is going to be the hypotenuse, one leg has to be opposite, and one leg would have to be adjacent. So the easiest way to figure out, well, which one is adjacent, and so adjacent may be the one that you want to figure out last. So when you look at angle A, the opposite one is if I were to kind of shoot something out of the angle, which one is it going to hit? The hypotenuse has to be opposite the right angle, which means whatever is left would be my adjacent. Okay, and then, so if I'm looking at the cosine, I'm looking at the adjacent over the hypotenuse, and if you look at tangent, looking at opposite over adjacent. Now, if I were to talk about angle B instead, I mean, these are all angle A, but if I were to talk about angle B, opposite of angle B would be what we are calling B here. The hypotenuse will stay the same, but now angle A is going to become adjacent. So for angle B, this would be opposite, this would be adjacent, and this would be hypotenuse. And then when you start talking about angle C, you don't ever use trig ratios for the hypotenuse because we know it is going to be across from the right angle. We already know that the right angle is 90 degrees. Okay, but so for example, the sine of A, which is opposite over hypotenuse, is the same as the cosine of B because B is going to have adjacent over hypotenuse, right? And so this ratio would actually be the same. And so often you'll see sine and cosine kind of work hand in hand depending on which angle you're talking about. So you may want to pause the video, kind of write down this example. We're going to use this to solve some problems. So now let's take a look at how is it that we would solve for the ratios here. And so if you're thinking about, okay, the sine of A, and we said that A, I'm going to take this away for a sec, we said sine is opposite over hypotenuse. So if I'm looking at A, opposite of A is going to be this, right? We know that the hypotenuse is coming out of the right angle, so I know the hypotenuse has got to be 15. So opposite is going to be 9 over hypotenuse, which is 15. Now I'm purposely not going to reduce that. So the sine of A is 9 divided by 15. I actually can figure out what that ratio is, and then that would help me figure out how many degrees, or the measure of angle A, and we're going to talk about how you use that a little bit later. To find the cosine of A, coming back to this, I'm going to need the adjacent over the hypotenuse. So I'm looking for adjacent of A would be here. So it's going to be 12 over the hypotenuse, which is 15. And then finally, if you're looking for the tangent is going to be opposite over adjacent. And so opposite of angle A is 9. Right? We already kind of figured that out on that first problem. And adjacent is 12. And so this is going to be 9 over 12. All right, so these would be my ratios for A. Now keep in mind, if I had used angle B, I would have different numbers here, though 15 would still be the hypotenuse. That won't change. whether I use angle A or angle B. Just opposite and adjacent will change. All right, now let's talk about using the calculator, how it is that we're going to use this to figure out some math. And we'll talk about how you could type this into a scientific calculator in a second, but if I wanted to figure out what is the height of this ramp, let's pretend like it's a skateboard ramp. I want to figure out what's the height of the skateboard ramp, and I know that this angle here is going to be 10 degrees, and I know that the hypotenuse, right, the actual ramp, is 5 feet. I can figure out this length, but it's not really asking me what this length is. It wants to know how high is this ramp. So if I'm thinking about angle 10, I'm looking at opposite of angle 10, and this is the hypotenuse. So I want to use the ratio that's going to talk about the opposite and the hypotenuse. And so if I'm looking over here for which one is opposite and hypotenuse, you'll notice tangent talks about opposite and adjacent, but I don't know the adjacent, because this would be my adjacent. So this ratio won't help me any. This one won't help me any because, again, I don't know the adjacent. I do know the hypotenuse, but I don't know the adjacent. So I'm going to use hypotenuse, opposite and hypotenuse, which is going to be sine. So I know that the sine of 10 degrees equals the hypotenuse, the opposite over the hypotenuse. Now, my problem is I don't necessarily know what h is yet. But if I were to go and use an algebra trick and multiply 5 to both sides, and keep in mind this is just a number, and if I type it into my calculator, sine 10, and hit equals, a number is going to come out. But I'm not going to do that just yet. These two, right, because this is the same as 5 over 1, this and this will cancel out. So I'll be left with h on this side, and I have 5 times the sine of 10. So if now is when I'm going to need to take out my calculator, I'm going to type in sine of 10 times 5, and I end up getting 0.8624, right? And so I'm going to end up rounding to the nearest tenth. And so if I round to the nearest tenth, that means that this is going to tell me that I need to round up. So I'm looking at 0.9 feet as my height. All right, so that's one way that you might use trig to solve a real-life math problem. Now let's take a look at another problem. Which one do I want to do next? Sorry, I had my board on the opposite. All right, so if I'm using this, and this is called solving the right triangle. So when you solve the right triangle, what I'm going to do is I'm going to find the measure of each of the 3 angles as well as the length of each of the 3 sides. And so the question is, how do we do that? So let's start with finding angle A. So to find angle A, there are a couple ways to do it. Probably the most logical way is to say, okay, I know that the 3 angles have to add up to 180 degrees. So I know that angle A, let's just call it uppercase A, plus 41 plus 90 has to equal 180. Right? And so I know then that this is going to be A plus, and if I go 90 plus 41, I don't need my calculator, I don't know why I'm starting to type things in there, is 131, and then I get 180. Tell you guys never to use your calculator, and here I am typing things into my calculator. Now what I need to do is subtract 131 from both sides, and you end up getting A equals 49. Right, so that's minus 131 here, goes away, and then minus 131 here, and that equals to 49. So I know that this is 49 degrees. Okay, so I've now solved that part of the right triangle. I know all 3 angles. Now, if I want to find angle side A, there are a couple of ways I can do that. One would be I could use angle B, and I could say, okay, I know that opposite is 6, and I know that the adjacent is A. Another way would be to use angle A. I know the opposite is A, and the adjacent is 6. But keep in mind, I still don't know necessarily what the hypotenuse is. I'm going to do that next. So if I want to go, and I'll go in order just because A is lower in the alphabet, and let's say I'm going to use, let's use angle B. So I know that this is, from B, I know the opposite and the adjacent. So now I want to figure out which of these talks about opposite and adjacent, and that's obviously tangent. So I know then that means that the tangent, let's use green, so I know the tangent of 41 equals the opposite, which is 6, over A. Okay, now, what I would need to do then, if I want to try to figure this out, is I'm now going to multiply A to both sides, because I don't want A to be in the denominator. So this becomes A times tangent of 41 equals 6. And now what I need to do is divide tangent of 41 to both sides. Right? And so this cancels out, and I'm left with A equals 6 over tangent of 41. Now what I can do here is take my calculator and I can type in 6 divided by, and I'm going to go tangent of 41, and I end up getting 6.9. So I know that A is, I guess it's, A is 6.9022 dot dot dot, right? So this is going to be, A is approximately 6.9. So I know that this now equals 6.9. Now my problem is that I can't necessarily, I could use the Pythagorean theorem if I wanted to and go a squared plus b squared equals c squared, but the problem is that I rounded to get to the 6.9, right? 6.9022, and it kind of keeps going on forever. So I don't want to use the Pythagorean theorem because I'm going to end up having to round to find that. So if I want to find c, which is now the hypotenuse, I have a couple of different ways that I can, ones I can use. And so I can either use sine of an angle or cosine of an angle. And so since we used angle B for this one, let's use angle A over here. And so I'm going to use opposite over, or no, let's use adjacent, because I know that 6 is an exact number. I want to try not to use this side if possible. So I'm going to use adjacent over hypotenuse. And so if you, or adjacent hypotenuse, if you look at which of these uses adjacent hypotenuse, that's going to be cosine. So I'm going to say the cosine of angle A, so the cosine of 49 equals adjacent, which is 6, over C. And so now I'm going to end up doing the same thing I did on this problem. I'm going to multiply C to both sides, so I get C times the cosine of 49 equals 6, right, which is similar to the step I did right here, times C. The C's will cancel out, and then the C is over here. And then I'm going to divide both sides by the cosine of 49, so get cosine equals 6 over the cosine of 49. Sorry, that's a 6. All right, now what I'm going to do is say 6 divided by, and then I have to type into the calculator cosine of 49, and this is going to equal 9. What column am I using? Here we go. 9.1455 dot dot dot. And so now what I'm going to end up having is the C is approximately 9.1, right? Because this 4 tells me to leave it the same, and so I know this is approximately 9.1. Now, a couple things to make sure that you have here. One would be that, common sense tells you that the hypotenuse must be longer than either of the other two legs. So just make sure that when you find the hypotenuse, it has to be larger than the other two legs. Now, a squared plus b squared equals c squared. It should be approximately right, but you will, since I'm rounding here and I'm rounding here, it won't necessarily be exact. All right, and then the last type of problem that I want to make sure we know how to solve is what happens when I know the two sides and I want to find the measure of angle x. So if I wanted to find this leg, I could go 8 squared plus b squared equals 19 squared. I could find out what this is, but that's not what I want to do. What I want to do is figure out what is the measure of angle x. And so I know that if I'm looking at angle x, this is opposite of angle x, and since this one is opposite the right angle, 19 would have to be the hypotenuse. So I'm looking for the one that deals with opposite and hypotenuse, which is the sine. So I'm going to do sine of x equals 8 opposite over hypotenuse. Now there's an easier way to solve this, and that is that because I don't know what this is my unknown, but I know these two ratios, whereas if you look at, like, for example, this problem, I knew the 49, I did not know the c. Right over here, I knew the tangent of 41, I did not know a, so I didn't know part of the fraction, whereas over here, now I actually know the fraction, I just don't necessarily know the x. So what this is going to turn into is, in your calculator, I'm looking for, and this is, a lot of people wonder what this is, I'm going to go sine of, or inverse sine of 8 over 14. And so in your calculator, oftentimes you'll have the sine button, and then if you hit the second function, you can get this. And so that's what I'm looking for here, is the inverse sine, and I need to go 8 over 19, and then you're going to hit equals, and so this equals approximately 24.9010 dot dot dot. Right? And so this, if I'm rounding to the nearest tenth, the 0 tells me to leave it the same. And so this angle is approximately 24.9 degrees. All right. I know that was a lot of trig to throw at you. So we're going to spend a couple days in class going over these types of problems. Thank you very much for watching the video. Don't forget to do the problems on the bottom of the page. I'll see you in class.